Okay, here's an Asus F556U laptop. It's already disassembled. Some notes. There's a lot of dust accumulated in here between the heat spreader and the fan assembly inside here. So this has to be like destroyed to get there, but it's worth it. Or maybe we can try it with some needle and try to get it manually out. We'll see. And here I lifted the motherboard. I kept this connector attached because it's fragile. It doesn't just come out easily, so I just left that side attached. And we're gonna get rid of the plastic insulation layers and put some thermal pads, of course, underneath CPU and the GPU and the memory there. So I've took the plastic layer that was glued on top, on the bottom of the keyboard here, and I translated it to the motherboard, and then I used a cutter to cut the holes where the most important parts to cool are, so I can now transfer it back to its position and place the thermal pads accordingly. I'm also using a mixture of epoxy glue and cloth, like fiber cloth, synthetic cloth, to improve the hinges structure. It's messy, but it works. It's gonna prevent any hinge damage in the future. And here we are with all the thermal pads stopping, sitting nicely. So these are 3mm thermal pads cut in kind of a square situation. And you see here, I forgot before to cut the holes for the memory that is soldered on the board. And these are 1.5mm pads sitting on top of those bulges here that correspond to these things that hold the screws for the cooling system. Now here I'm placing those thermal pads where the metal heat spreader has these surfaces, but I sadly don't have thermal glue currently available in my shop, so I hope that they stick to the position when I just push them down. But yeah, ideally I would use thermal glue here. Machine is almost reassembled. I swapped the Wi-Fi card with a dual antenna one. Previously it was just one. I'm gonna set the antenna probably there, up there. The thermal pads here stick perfectly. I can see them from the border. And what else? I decided to go with some plastic material that I cut here for the SSD instead of the cage to save a little bit on weight, I guess. And as I turned on the machine the first time, it spits a lot of dust still. Some dust was also accumulating here, and I had to take it out with the fingers. And now it seems perfectly clear. So now time to run, get some tests, see what happens. Okay, so in the usual Asus bullshit style, we can't install the drivers on this 920M GPU because somehow it's locked to original drivers only, like from Asus. We cannot install the official NVIDIA ones. So I'm just testing the CPU on the test drive. Now, before doing all the modifications on the thermals, on the change of thermal paste and everything, I already did all the stress tests with OCCT, Limpac and everything on the CPU, and I came up with these values you can see up there. And these are all like double tested, triple tested with all kind of stress tests. And on this system, which is a Skylake, the CPU and CPU cache offsets are separate. They're different values. And I think also the iGPU and the iGPU analyzers are separate, and the system agent, as always, is on its own. And these are the values that are sure to be working with all the tests that I can run, like Rancher, Limpac, and everything. They take a long time. I've been testing this machine for 1 month because every run of every Y Cruncher, everything takes ages. This has 12 gigs of RAM, 4 gigs are soldered, and 8 gigs are on a single DDR3 DIMM. And yeah, let's just run Geekbench 6, and then I think I'll move to the client drive with a fresh OS install and deal with the driver installation for the GPU, so that I can also run Firestrike, for example. We're now in the, I think, multi-threaded area of the test, so we're reaching like 15 watts at some point, and the maximum temperature is 63 degrees so far. So that's nice. But the fan is ramping up a little. Like it's actually spinning. As always, the fan curve is like all over the place, and it doesn't have any correlation to the CPU temperature. Doesn't seem like. And the fan is just blowing cold air. So I ran the test 3 times, and the peak power consumption was 16.4 watts. And this is the latest result. Then we had this one before, and the first one was this one, which happened during when I was actually moving the windows. And the average for the CPU are these ones. Cinebench R15 without high priority, 277 points and a maximum of 14.6 watt. And this is with high priority. I'm now trying to run Cinebench 2026, and it's struggling even to prepare the project. And 45 minutes later, at 71 degrees, 22 watt peak, we got 458 points for this i5. Okay, I'm on the customer drive, and I'm using NV Clean Install utility from Touch Power Up, just as throttle stop, to try force the driver installation for the GPU. Let's see what happens. And now I found out why it's not working, because this is not a real 9 series GPU, it's a 7 series, it's a Kepler GPU. And yeah, that's a scam from Asus, as always. And since I also have a couple of drivers that are outdated, I just gave driver booster a go, and it's gonna also update some Wi-Fi and Bluetooth drivers from Qualcomm. So yeah, I surrender. Like, driver booster is useful, saves time. That's true. Okay, so a couple of other tests on the system drive. Now with the best Geekbench score we were able to get, then OpenCL score for the Kepler card. Well, yeah, CUDA here. Some Geekbench 7 results. Another Geekbench 6, I guess. Yeah, another Geekbench 6 result. And Y Cruncher 1B. And then I had to lower the undervolt a little bit, like on the CPU. I had to set 115 just to be sure, because at 120 and 125 I got crashes in Warhammer 40k Dawn of War 1, which is the only game that the owner plays. And so yeah, I had to lower it to 120, no crashes, and to be sure I just put it at 115. I try now to game with Warhammer 40k on the external screen, see if you can do that. So only way I found to get the proper resolution on the game was to disable the internal display and only show on the external one. I guess that's Windows at its best. And yeah, that's an 8-player map, so we'll really see how it works. I don't know how to enable a performance counter. It's just gonna be like a random test. I'm just gonna play a game and see how smooth it is. Okay, I'm just losing the game. A couple of seconds, I think I'll be done. But it was worth a fight. And yeah, game's pretty smooth, super fun, no problems, and the settings were as follow. And you don't need a high-end GPU or a high-end computer, just a dual core, a Kepler GPU, and you have all the fun you need. So that is all for the video, I guess. Ciao!